All right, I think we'll get into this. Thanks everyone for being here. Welcome to the November Sustainability Series. We're excited to welcome Ben Heymer from Slipstream to talk about Sketchbox, which is an energy modeling platform to help folks understand how buildings consume energy, and a kind of parametric tool to help evaluate different energy conservation measures. We're excited to welcome Ben to talk about it. As usual, if we could have folks maybe type questions in the chat through the presentation, and then we'll have some time for kind of group Q&A at the end as well. That'd be wonderful. I will share the recording of this and a couple slides from today's presentation. And we'll also include a link in here so folks can look at the tool as Ben is working through his presentation as well. But overall, just want to thank everyone for being here. I'm excited for this. And yeah, take it away, Ben.
All right, thanks, Kevin. So yeah, my name is Ben Heymer. I'm a professional engineer. I've been in the energy efficiency industry for a long time, and worn a lot of different hats as a energy consultant, as a working for an architecture firm, MEP firms, design build contractors. So done a lot of different jobs, and really excited about our current project here, which is called Sketchbox. And the goal of this really is to get energy modeling into the hands of more people, expand the user base of people who are able to use energy models to make design decisions, especially early on in the design process, and just make this generally more used and more available for all different kinds of projects. It's been around for a long time, and it's often used to optimize, really high-profile projects like, university buildings and hospitals and things with really big budgets and really sophisticated design teams. But it's really being underutilized, I think, for a lot of the smaller projects, spec office buildings and other, retail buildings and schools, and just all kinds of projects can benefit from model-based design. And I'm really excited about this tool because it gives us an opportunity to just expand the use and get that in the hands of more people, and show people how they can make their buildings more efficient or decarbonize their buildings without really adding a lot of additional cost to the project. So I'm Director of Engineering here at Slipstream, lead a team of engineers out of our Chicago office. We do a lot of work for programs. We run utility programs for energy efficiency. We do research. We do some education and some policy work as well. A few years ago, we worked with the Mayo team on the Generos facility expansion, where we worked with the ownership group really early on to set energy targets for the performance of the building, and that really drove a different kind of architecture and design philosophy that might have been done status quo, and I think resulted in a really cool building and much more efficient than that would have otherwise been. So hopefully we can apply the same sorts of strategies and lessons on all kinds of projects. So without further ado, we'll kind of get into some of that discussion. And again, I want to keep this really informal. So if you do have questions, put it in the chat, and we'll try to address those in real time. And I'll leave plenty of time at the end too for some discussion. So just a little metaphor. So I'm a woodworker is one of my hobbies, and just recognizing that to do a job, to build a piece of furniture or to design a building, we use a collection of different tools. And I think we just need to be okay with that. You know, it's you can build an entire table with you know, a hand plane if you wanted, and it would just take a very long time, and it just wouldn't be a good use of time or resources. Um, so I think we as engineers, and especially as energy modeling practitioners, we just need to be fluent in skilled in the use of a lot of different tools, which are used in different phases of the process to, you know, turn a tree into a chair, for example. It's the same with building design. You know, you need to use tools that are rough and fast at the beginning of the process, and become more refined and more detail oriented as you move on into the last parts of the process. And we as energy modelers, as energy consultants and practitioners, have been for the last, you know, 20 years at least, mostly focused on the end of the process. So putting together these very complicated, very labor-intensive models that are used for code compliance, for certification, you know, things like LEED and Green Globes and Passive House and all the certifications that you might be familiar with. So that's where we've focused most of our effort in this industry and in this field. That's where all the advances in tool development have really been, is in that last step. But the problem with that is that, you know, we're missing these early opportunities to use tools to really make better design decisions. And of course, the earlier you make good decisions, the cheaper it is to implement, the less disruptive it is to the design process. You know, all the cost, all the fees, all the effort associated with building, you know, much better buildings, you know, is should really be focused in this schematic design phase, or even earlier in the planning phase. So basically, my pitch here is we need to have some better axes, and we need to be more familiar with their use, and not be afraid to do that, even though you may have to, you know, build more models later on in the design. It's still just such a valuable effort to get a design going in the right direction. So I'm going to switch over. I can talk about this really quickly. So, you know, Sketchbox is at a high level, it's a web-based interface and a cloud-based interface for modeling tools that already exist, that were produced by the US Department of Energy. So in this case, it's the DO2 platform, which is the same energy modeling engine that's used by eQuest and, you know, some other really robust industry standard tools. And although they're not, you know, what's considered to be like the cutting edge of energy modeling engines, they're kind of workhorses. They're fast and they're reliable, and they're definitely good enough for the kinds of, you know, rough early modeling that we're really optimizing this tool for. So we've been using this internally for 6 or 8 years or something, in various forms, and it's been evolving. And we originally built it just for ourselves, so we could do better, faster work and be better energy consultants here at Slipstream. But a couple of years ago, we realized that, you know, we've done something kind of special here, and it's, you know, it's worth sharing with the world to further our impact and promote our mission of providing climate solutions for everyone. So we made some improvements recently. Now we've made this public, so anyone can go get a free account. And we also have a low-cost subscription-based model, which we can touch on. But really, you know, we designed this to be accessible. So we want to try to minimize the jargon and the industry-specific knowledge that goes into energy modeling, provide a more intuitive workflow, something that can be used, you know, on any computer without installing software, any phone, any tablet. It's kind of cool to be sitting in a design meeting and doing this in real time, instead of, you know, waiting 2 weeks for results. It's, you know, applicable to, I would say, 90+% of projects. There are some things that I wouldn't necessarily use this for. Really complicated hospitals and laboratories, can benefit from this type of early analysis, but really do need more detailed models to be built later. But, something like retail buildings, office buildings, multifamily mixed use towers, some of those buildings are pretty simple. They have simple HVAC systems, relatively simple programs and geometries, and you really don't need anything more complicated than this. We also try to validate all of the inputs and outputs of these models so that it's really, I would say, almost impossible for a user to break the tool. I spent a lot of long nights in the office, trying to debug my energy models like the night before a presentation or a paper is due, and that's no fun. And that doesn't add any benefit to to the client, to be spending all your time debugging software rather than acting as a good consultant. So again, fast speed is important, getting results in real time as these designs evolve, and making it actionable through built-in processing and really detailed results that go above and beyond what we're used to seeing from energy analysis. So anyway, the link is below. I encourage you to check it out and create an account and play around. So let me switch over to the tool. I guess I can just show you this landing page here too briefly. So this is a summary. We've got some video content, some descriptive content, link to the tool. I can just touch on the pricing here. So again, you can get a basic version of this for free. And we've tried to make our standard or subscription offering very low cost. So it's only $149 per year to get more shells or program elements of the building, which we'll touch on in a bit. You get the access to the raw or the native DOE2 engine files. So you can, it's not a black box. There's no questions about how things are being done inside the tool. You can go poke around for yourself using other free software. And we can also, customize this for utility partners or, PACE financing partners or anyone that wants to do something special with this tool. That's also an option. So let's, I'm just going to refresh and we'll start with a fresh model and you can see how this works. So again, this is just a website. Here on the home screen, we have the ability to define a new project. So let's just build a new one. I'll zoom in a little bit more just so it's clear for everyone's screen. So we can select a location. Let's select Rochester. What energy code are you all working with at the moment? Anyone want to chime in?
2016, I think.
Okay. So yeah, so ICC 2018 with ASHRAE 2016 as the compliance pathway. Perfect. Okay. So we have the ability to define a few things here. Financial information, emissions ratios, site to source ratios. One thing to note here is that part of this intuitive dynamic workflow is these dynamic defaults. So any text that's in blue, like cost of electricity here, this is being pulled from a database of other, based on your inputs. So right now, 9.9 cents per kilowatt hour for Minnesota. That's the EIA average. If I change this to, somewhere where I know electricity is really expensive, like Hawaii, that's going to jump up to, 25 cents a kilowatt hour. If I know that I have better information for my project, I can override all of these defaults. Let's say I know it's 21 cents for my project. So that value turns from blue to black. it no longer is tied to the location. So if I change back to Rochester, it stays at 21 cents. If I want to restore that default, there's a little recycle symbol here, and I can do that. So again, trying to make things as easy as possible and automate a lot of the looking up that we need to do to define these buildings, define these values. We do have a support forum and some documentation down here. We have the ability to save and reload projects. There's a couple ways to do that. You can save it to the cloud, or you can save it to a file that you can share with other users or send to support request or something like that. And again, if you're a paid user, you have access to the archive. In other words, all the input files to go to. All right, so moving on to the fun part, which is building a building. And yeah, let's continue to make this interactive if it's possible. Does anyone have a building project that they're thinking about or working on that we can start with? If not, I'll have to make up some goofy building.
I could be patient and wait. But I guess we're looking at a high-rise residential building.
Okay.
12 stories tall at the moment.
All right, let's go with that. So multifamily, residential. So we have a few things we can do here. One is you can have different building components. Like I imagine there's probably a parking component to this.
Mm-hmm.
So we can add a parking garage. We can add a bunch of different things and stick them together. You can have your distribution warehouse with the office attached. You can have your mixed use towers. You can have different things arranged in different blocks. So I have my parking garage. I can put I can attach retail to this surface. I can separate it. I can stack them on top of each other. I can even put things inside of other things, which can be interesting. Like for example, sometimes you see that there's some retail that's sort of exists interspersed within maybe a hotel or some other type of building, and it doesn't really have any exterior exposure of its own, but you want to analyze the different loads, the different HVAC systems, and other things that are happening in there that are a bit different than the host shell. But that doesn't really make sense in this scenario, so we'll just stack it on top. Okay, so we can define some things here too. Maybe the parking garage is, I don't know, let's say maybe 10,000 square feet on 2 floors. Does that sound about right? We can play with the aspect ratio too, which is just the length divided by the width. So a value greater than 1 will give you a east-west oriented building. A value less than 1 will give you more of a north-south oriented building. Let's just leave that at something relatively square. So there's a parking garage. We can play floor-to-floor height. Let's do more on our residential tower. So let's say, I don't know, 40,000 square feet. You said 12 floors?
Yep.
So looks like we'll have to add some square feet.
Yeah, 250,000 maybe.
250, all right. 250,000. And again, these are variables. This parking garage is way too small now, isn't it? That's more like it. Anyway, as you're working through a real design, you'd spend a little bit more time thinking about these inputs. But again, the purpose here is to be able to very quickly define the geometry, not worrying about every little nook and cranny and facade detail, but just getting the bulk, massing right for for the building, and getting on to the, the fun part, which is thinking about energy efficiency strategies. But before we're done there, we have the ability to select some different, types of walls and roofs, fenestration, window to wall ratio is something that you can vary by facade, and you do get some visual indicators there. So starting with 40% is usually a good thing. We can have skylights. That probably doesn't make sense for a multifamily building, but that is possible. And then we can start defining our HVAC system. So what are you thinking? Is this natural gas or electric heat?
We're hoping for electric heat pump system. Yeah.
Okay. Yeah, so within that we have, different kinds of heat pumps, air source heat pumps, different kinds of packaged heat pumps. There's, water source heat pumps, ground source heat pumps. There's a, VRF type system, which is becoming more and more prevalent. We also have the ability to have outside air systems. And within that, you can choose a gas-fired rooftop unit, which is still relatively common in our climate. Or you can have that be similar to the primary system. So in this case, also an air source heat pump type product. For domestic hot water, you can select natural gas, electricity, or heat pump, and define your water consumption. So we did the office. Switching over to the parking garage. Here we have a few more options. Maybe that's too much glass for the parking garage. We can reduce that. We can serve that with, like an electric heating, probably heating only system would make sense for that. Okay, so we've defined our building. So instead of spending all week, redrawing an architect's geometry in my energy modeling tool, we now have a model, and if we jump over to results, we'll make sure that it runs before moving on. It runs 99% of the time, but this is a live demo, so there's always a chance that something will break. But okay, so so we got our model running with two different shells or program types. And again, I could keep adding these things if we've got some retail attached or restaurant, or there's a hotel component or something else within this project. We can do lots of different things, and even put them together in T shapes or L shapes or whatever makes sense for the project. So moving on to schedules. By default, we're just loading up schedules from like the ASHRAE handbook. So for a residential property, we've got this inverse occupancy profile, some different profiles for ventilation, lighting, hot water use. You can just choose to use these, which I do for most things. But you also have the ability to define your own simple schedule, which, especially for something like retail or manufacturing, might make sense to just know that, this is a 6 a.m. to 11 p.m. parking garage. And then you get a simple ramp up, ramp down kind of function with the ability to like specify your min values and max values and play with those a little bit. This is also where you can adjust your temperature set points if different than a typical building operation. But again, this is intended to be really easy, and mostly you can just accept the ASHRAE schedules and move on. Same with this baseline tab. So all of the values from the energy code that we selected populate into this summary of the baseline building description. So we know that the roof U value by energy code has to be 0.032. Wall U value glazing performance, interior lighting power density. We have different requirements for a multifamily building than we do for a parking garage. So all these are dynamic based on the energy code. So you can come in here, you can review and edit these. Sometimes there's cause to edit parts of this, like if you want to specify humidification, if you know that your ventilation rate will be a little bit different than the ASHRAE 62 ventilation rate, or you just want to tweak some things, you can do that here. The other reason to use this and come in and make edits here is if you know that you're starting with an existing building. So maybe you have a building that was built 20 years ago. Selecting an older energy code doesn't necessarily capture everything about that building, perhaps. So you could come in here and you can modify your wall U value. If you know you have uninsulated masonry or something like that, you can come in here and make some edits to your baseline. And again, this is just your baseline building. This is your starting point, and the next step is defining our energy efficiency strategies. So again, mostly, especially if it's new construction, we can kind of blow past this baseline tab, check a few things, but know that, all this stuff is getting looked up from the code, which, it saves hours and hours. So measures, you can create a measure based on just about any parameter in the tool. And so we can talk about that real quickly, because this is a great tool, a great way to just answer really specific questions about a design. For example, we could say for the glazing, what I really want to know is, can we save some energy by moving glazing around on the building? So, I have to name the measure. So glazing orientations, I want to look at north and south. I don't really care about the parking garage. I just care about residential. So we'll just add that one. So now I'm presented with this kind of a menu. So I started with 40% glass. And I know that, high quality daylight is coming from the north. So what if I move some of my glass to the north and take that same amount of glass away on the south facade? So I can run that. It's going to run a couple models and deliver results, usually within a couple minutes or a few seconds even. Okay, so here, my efforts to move that glass saved about 1% of energy use. So, not inconsequential. And that energy came out of heating, came out of the cooling energy, I think, but did cost me a little bit more in heating. So that's, one specific question that I can answer pretty quickly with something like this. But the other thing you can do is just load up our default measure set, which includes, all the usual suspects for energy efficiency, roof insulation, wall insulation. You can see here, we have kind of a good, better, best interface. So you can select no change, or using the code value, you can select better, you can select best, or you can put in your own custom values. These are pretty easy to navigate to collapse. You can even drag and drop to reorder these and run these measures in a different order. My consulting philosophy usually is to kind of go from outside in. So first optimizing the envelope, then reducing the loads like lighting and equipment, then serving those with the more efficient HVAC system, and finally applying different kinds of controls to optimize those systems. But really, you can look at these in whatever order you want. A common question is, how do these all get combined and rolled up together? We are running the model for each one of these improvements, or each one of these steps or measures. I think that's really valuable because it gives you insight into which of your strategies are actually impacting the energy performance of the design. which is something you don't get in the traditional sort of lead energy accounting approach, where you're just looking at your baseline versus your proposed and your percent savings, but you really don't know where that savings is coming from, and it doesn't give you a lot of direction in terms of your design decisions. So we run them all individually, and we run them all progressively, meaning that, you know, this upgrade roof insulation measure is an improvement upon the baseline, but the next model run incorporates the roof insulation and the wall insulation. The third model run, you know, incorporates these three. And by the end of the list, you've applied all of the measures in the model and you see the end result, which is your proposed design. That's a little bit confusing potentially. If there are questions on that, I can help clarify further, but that's our approach and our philosophy.
We did have one question in the chat, Ben, around, this seems to be, or at least the example we're looking at is more new construction focused. Is it possible to look at existing building built to an older code and use it for like energy conservation measure evaluations too?
Absolutely. Yeah, you'd follow exactly the same process with maybe one tweak. So here, you know, this is the new energy code, the latest energy code. If you were working with an older building, what I would do is I would start with an older code like ICC 2006 or ASHRAE 2004, for example. I would use that as my starting point, or whatever other code you thought was appropriate. I would start there, and then I would spend some time adjusting my baseline values to represent that building as closely as I can, as closely as I have information for, which might involve, calculating some U values for, whatever wall system that you think is there, plugging in values from, let's say, the nameplate of the HVAC equipment that's there, or just some assumption that you found. You can tweak a lot of this stuff. You might not know exactly the lighting power density, but you might be able to estimate it. And then when you go to run your first results, and if you have utility bills that you can actually kind of roughly tune and calibrate these to represent an existing building. So, I do that too. I'll play with, this infiltration value, which is, something that's really hard to know or measure in an existing building. I might play with equipment loads. We've got this value for plug loads here somewhere. Where did that go? Here, like 0.25 watts per square foot. If you're working with an older office, that might be close to 1 watt per square foot. So you can tune some of these lesser known variables to try to line up with some utility data if you have it. And then you've got a great starting point then to start applying some energy efficiency measures in exactly the same way that we think about new construction. The exciting thing is that your energy savings are just way higher. So that can be fun. Okay, so again, back to this process. So, glazing, maybe I'm not interested in the best glass on the market. I just want the better glass, so I can do that. Just kind of collapse these so it's easier to see some of this stuff. And again, there's some engineering judgment built into these recommendations. So, we know that for, interior lighting power, we can achieve 0.32 watts per square foot. That's like a best practice lighting design. I think that's actually exact same LPD that I was able to achieve in my home renovation a few years ago. And for parking garage, that value is very different. We're starting with 0.15 and going down to maybe 0.06. You can also plug in your own values. Like if you know that, I talked to my contractor, I talked to my lighting designer, and our proposed value is 0.07. You can plug in your own values here. These are just meant to be guidelines and suggestions for target values. We have values for task tuning. If you're not familiar with that, that's just adjusting the maximum light level in your LED fixture, which can save significant energy, especially in like education and office buildings, maybe not so much for residential and parking garage. If you don't like a measure, let's say, for this maybe task tuning isn't really that relevant, so I can just delete that. Occupancy controls, controls are required by code in a lot of places, but we can still improve upon those by reducing those time delays, by controlling larger fractions of the installed lighting. So you can look at that and plug in your own values. Exterior lighting, equipment power, cooling equipment, which applies to the residential but not the parking garage. Heating equipment. And here, demand ventilation controls, maybe those aren't really relevant to the residential, so I can delete that. Again, here, low flow fixtures, not really relevant to a parking garage. And water heating equipment. Okay, so I have my list of measures. These are the default measures. I can also add my own if I want to look at, things like overhangs on the glass or, different ventilation values or anything. I mean, we can answer all kinds of different questions, but all that gets sent up to the cloud, and we're using, in this case, 23 different models that are all running, and it'll all come back together, and we'll be able to compile all our results and understand what's driving energy savings in this project. Okay, so high level summary, our net result is 32% savings on energy cost. We're using no natural gas. We can see our site and source EUIs and our equivalent CO2 emissions values. One thing I really like about this tool is that all these charts are dynamic. So, maybe energy cost isn't my primary driver. Maybe it's CO2 emissions, maybe it's site energy. So you can change all that. You can even, I'm not sure why you'd necessarily want to, but you can even like hide these chart elements. So this is all pretty interactive. But anyway, this shows our energy use by end use. So, heating versus cooling and fans and lights and plugs. And it shows that reducing over time as we apply each of these additional energy efficiency strategies. And again, we can, we have some controls here. We can normalize that by square feet. We can save these images for use in our presentations and our reports. This is just a slightly different view. So this is showing the baseline and proposed design by month, which is, kind of nice to see that your heating is happening in winter and cooling is happening in the summer. This is the chart that I by far spend the most time on when I'm consulting with clients. This just shows the incremental energy efficiency impact of each of these strategies in relation to one another. So again, we can change these things if we care about peak cooling load, peak heating load, source energy, CO2, that's all dynamic. And, in this case, improving upon the roof insulation that's already required by code offers us, almost no benefit. So that's something that I would say at this point in the design, we can stop thinking about that. We can stop talking about it. We don't need to worry about the cost of adding new roof insulation because it's not really doing anything for us. Let's move on to more impactful conversations like air sealing, sealing up all the little cracks and penetrations in that building is far more valuable than the roof insulation and the wall insulation in this case. So, that's something that in a conversation with an architect at this point in the design, you can really make a big impact on the performance and, also keep everyone focused on the end result, on the whole building performance rather than on these little distracting details perhaps. So again, we're at the point of diminishing returns on a lot of these things already for wall insulation, glazing, interior lighting, still a great measure, still really important design feature for almost every building out there. There's definitely an opportunity here to optimize that through some of the control strategies. But maybe, maybe we don't worry too much about exterior lighting controls. We just do what's required by code. Here again, like demand ventilation controls for that parking garage. That's one of the most important things we can do on this project to save energy. So not just do what's required by code, but go above and beyond to make sure that we're delivering no more ventilation than is really necessary to keep the air quality of that parking garage safe.
I had a question on that
yeah.
one, Ben, in particular. So I think in the measures or whatever you said, demand control ventilation would be for both the residential tower and the parking garage. Is it able to bifurcate that between those two space types to understand the savings for one versus another?
Yeah, so I did delete the residential component of that. So that's just the parking garage, but we can actually add, we can go in and add back a separate measure for residential. Let's see.
Sorry to throw things at you in real time, but
no,
thank you. It's cool.
It's good. So just call it res DCV, only on residential. I'm going to move that down, group it with the other one. All right. And, some of this you sort of have to take with a grain of salt because, this is just the model is pairing these occupancy schedules that we defined with the ventilation rates. When it comes time to get into the design details, sometimes there's factors here that, might result in some different values. So we have to keep some of those things in mind. These are still bulk building models, based on, pretty broad assumptions about how the buildings will operate. But still, I think the point really here is to create these order of magnitude type of analyses so that we really understand where to focus our time and efforts. We know that demand control ventilation for the parking garage and also the residential, if that's possible within the mechanical design framework, and is a really great opportunity. So, what I would, as an energy consultant, my takeaway here would be, yeah, for sure, we need to come up with a plan for air sealing. We need to have a really awesome interior lighting design. We should pay attention to the cooling and heating equipment efficiency, certainly, but we should pay more attention to how that ventilation is managed and controlled. And then also, hot water savings here at the end is a significant opportunity here too. So if we can use low flow fixtures, if we can use a heat pump type water heater, that's a big opportunity for this project. And, it's that easy. We've created a model really quickly. We have these actionable results. And this might not represent, every detail in the design, but, this is our axe. This is our first pass. We're kind of roughing out that shape of the building, and these things will be further refined as the design progresses. But, this kind of information is just missing from the early parts of schematic design and of planning for so many projects. And I'm so excited to be able to, give people access to this kind of a tool.
This is great, Ben. Yeah, thanks for leading us through this. I'm particularly excited too, because in Rochester, for projects to access public financing, we ask that they set an energy target and then run parametric runs of an energy model very similar to this tool to help us identify what strategies they're using in order to reach that energy target. So tools like these, I think, will be phenomenally helpful for local designers here to Rochester.
Great.
I didn't want to break up your flow, but
no,
if you're open for questions.
Yeah, I think we've reached a good stopping point.
Cool. So yeah, at this point, I don't know if folks here joining have questions for Ben, but fire away if so. I guess I'm particularly interested for some of the designers that are on the call, like Corey or Alex. Perhaps Kate too, given that you answered that energy model or that energy code question pretty readily. Is a tool like this helpful? Is this something they're already using as part of your practice? Those are some initial curiosities I have.
Sorry, was that a question for me or for others on the call?
I was trying to call a couple people out who are on the call.
Okay, yeah.
They're ignoring me.
It's all right.
For me, I'm not in private practice anymore, but I'm thinking of on the owner side, prioritizing projects for our existing buildings, creating a quick model of our buildings, and then, yeah, coming up with those scenarios of maybe what we should tackle first, different upgrades. And then if we're maybe studying if we should be renovating a building or if we should be building new, I think this tool could come into play with that as well and help us do some of that due diligence.
Yeah, we've started planning for some other features here that would make this a little bit easier to use. I described just with words the process of taking existing utility data and kind of trying to match that up to performance. I think it'd be really cool if you could actually just enter that utility data in here, and we have the power of cloud computing, and we could, the tool could even suggest which variables might help you align the model to your existing data. So that's something that we're considering for and planning for, which I think could be really cool. I'll also mention, some of our hopefully soon future upgrades include economic analysis. So the ability to assign like a capital cost to each of these improvements and then see how that plays out for life cycle cost and payback and ROI and all of those exciting things. The same exact framework with embodied carbon and all the things that it takes to build a building and implement all these different improvements and how that plays out over the life cycle. And then the other big thing on our list is having some basic like PV integration, so you can understand whether you've got a zero energy building or if that's impossible based on the parameters of your site and your roof area and your parking area and things like that. So encourage you to
question in the chat too, Ben.
Oh yeah.
Since it's saved in the cloud, would the model created be private or could it be viewable by others?
No, so it's you have your own cloud directory. So like, these are my list of projects. No one else can see my projects unless I download this file physically to my desktop and email it to someone. That's the only way to share projects currently.
Any other questions for Ben as we approach the hour?
Kevin, Dave Reichert.
Yeah, go ahead, Dave.
So my question would be around residential. It's a nice quick tool. I'm thinking with the Inflation Reduction Act money that's coming out, if you're trying to do 1,000 homes in Rochester and update them, it'd be great to be able to quickly model a home. You can make them all square as long as you could feed them a decent estimate of the R value of the wall, the windows, the roof, etc., and then play with those numbers, right?
Yeah.
What do you think, Ben? Would that work for something like that for that?
So I definitely agree that that has value. It's something that's on our radar. There's a couple things that we need to do before I would recommend using this for like single family residential. First is just the way that we specify the geometry of these buildings. If you're at all familiar with energy modeling, each of these design elements is your typical like 5-zone box. So we've got an interior space and then four
outsides.
perimeter zones that are each conditioned separately. So we've got 5 zones per floor that are each kind of separately conditioned with their own HVAC system. When you go to that smaller scale of a single family house, you know, you often have just a single thermal zone with a furnace. So you know, one approach is we could build that single zone component and allow people to access that through this tool. But before we do that, we just want to do some diligence and testing to make sure that the DO2 modeling engine, you know, appropriately represents that kind of building type. Some of these commercial modeling tools, when you get kind of that small, things get a little out of whack with like the volume of air versus the envelope and things like that, and you can get some goofy results. So it's something we're looking into and I'd like to do, but we just need to do a little more testing. And you know, it's for residential, there are other decent tools out there for doing things like that, like the HERS tool, and I know some other kind of more residential focused things that are out there. I don't do a lot of that kind of work, but you know, I'm sure there are other ways to do that. But again, I appreciate the suggestion. It's something that we'd like to try to do long term. Yeah.
Thanks.
Thanks, Dave. Any other questions for Ben as we wrap up here? Well, hearing none, Ben, that was a pretty amazing tool. Thank you for this presentation. I'm also excited to see some of those improvements, or not improvements, but additions you were mentioning around embodied carbon and cost scenarios too. I think that would be super helpful. But yeah, I'm excited to dig in. The energy nerd in me is excited here. So appreciate you walking us through it. And I do know it will have relevance here in Rochester. So I appreciate the time.
Awesome. Yeah. Thanks a lot for having me.
Sounds great. All right. Well, thanks everyone for joining, and we'll wrap up. And we'll be here next month to hear about some solar lease agreement opportunities to learn about. So thanks, Ben.
Thanks.